Hi, my name is Quick. This is my Physics Lab 1. So the question we want to determine is how to find the excess charge on a charged object. And so the two important concepts are electric field and electric force. So if an object has an electric field, then another charged object in that same space would experience an electric force. So Newton's second law comes into play, where we have the balance of forces would have to equal 0, and the only two forces that are acting on the top tape or the floating tape in the slab is the force of gravity and the electric force exerted on the top of the tape. So the assumptions that I assumed were I ignored air resistance and I treated tapes as point charges, and then I also assumed that the magnitudes of the charged tapes are equal. So the preliminary experiments that we did were to just determine if the piece of tape can be electrically charged. So I stuck a piece of tape on top of a base tape and pulled it off, and then stuck it on a desk, and then tested it with different objects to see if it would attract or repel. So with the U-tape in my hand, it attracted. With a U-tape and another U-tape, it repelled, and with the U-tape and a neutral book, it attracted. So the next experiments we did were just to determine, just to help with my understanding of positive and negative charges and whether or not they attract. So in this experiment we did, we made the perception of a floating tape. So we had to determine the gravitational, so because we assumed that Newton's second law, we had to, so the net force in the y direction is 0 based on Newton's second law. And so to determine the gravitational force, we found the mass of tape B, and I found that in our online textbook to be 1.6 times E times 10 to the negative 4th kilograms, and times gravity to 9.8 meters per second squared, which equals 1.568 times 10 to the negative 3rd newtons. So we had to determine the amount of charge on one U-tape. So by using the equation and plugging in the values for the gravitational force on tape B, the separation distance D, and Coulomb's constant, we found that the charge on one U-tape is 1.9 times 10 to the negative 8 coulombs, and we only found the charge on one U-tape because we assumed that both tapes had the same magnitude. And we found the number of excess electrons to be the charge of the tape over the charge of an electron, or the magnitude of an electron, which gave us 1.1875 times 10 to the 11 excess electrons. So the fraction of, we found the fraction of atoms that give up electrons by using the ratio, by finding the ratio of by using the atoms, the number of excess atoms and the atoms of on the surface of the tape, which gave us 1.19 times 10 to the negative 6 ratio. So I had to find using visual representation using GoScript code. So unfortunately, my code did not work, but the picture depicts how it's supposed to look, where you have two spheres. You have the top tape as a point charge for the top sphere, and the bottom tape as a point charge for the bottom sphere. And you're supposed to have two arrows stemming from the top point charge, one representing the electric force and one representing the gravitational force pointing downwards, and the electric force points upwards. So in conclusion, we have some basic principles saying that objects can have a positive, negative, or neutral charge, and like charges repel and opposites attract, and that the electric force acts along the line between charges. It increases rapidly as distance between charges decreases, and is proportional to the magnitudes of both charges. Some of the questions that we had to answer were, what if electrons what if electrons and protons, their charges switched? And then everything would be the same in these experiments. It's just that in the opposite direction, and it's important to handle the charged tapes as little as possible because you don't want discharge, and in that case, it will affect how well your tapes attract and repel certain objects because of discharge. So thank you for watching.